Okay, today we're going to look at velocity, which is sort of the main first topic in physics. We'll start doing some definitions today to understand differences between things, and we'll look at a few basic examples. A lot of this you would have covered in Science 10, so it'll be a good refresher for you. First thing up is the topic is velocity. And I also posted a picture of a speed limit sign, so a speed limit of 70. So my question is, first of all, what's the difference? What's the difference between speed and velocity and things like that? So before we get to that, let's just go through a couple of quick definitions. The first one is what happens in physics is quite often we have two sort of different words that sort of describe the same thing. And we just have to make sure we're clear on what it is. And a lot of times we interchange them, which is fine, but as long as we kind of keep it clear in our mind if we have to, that we know the difference. So the first definition we want to go through is what's the difference between a vector and a scalar. So a vector and a scalar can both basically mean the same thing, but basically the main difference is vectors have direction attached. So a scalar is just the magnitude or a size of a number only. So if I said you're going to drive 100 kilometers, that would be a scalar. But then if I said you're now going to drive 100 kilometers, but you're going to go north in the north direction, then it's a vector. So the key thing with vectors and scalars is vectors have direction attached. Most things we're going to use in physics will be vectors, and quite often we will sometimes slip up and say the scalar name, which is totally fine, and the calculations are fine. We just got to make sure we're clear on it if need be. So I mentioned this one, this distance, 100 kilometers north, that's an example. Another example would be saying 70 kilometers per hour would be our speed, that would be a scalar. 70 kilometers per hour east, that would be a vector because of that direction attached to it. So there's a lot of different things in physics that we'll be able to switch back and forth between the two, and the only difference is in terms of formulas. Quite often when we have vectors, we just label it by putting a little arrow, a little direction arrow over it. So if I was to write velocity as a vector, we just put a little arrow over top to indicate that it is a vector. Where if we were to write distance as a scalar, we just leave it as a D. If we were to write it as a vector, we'd put a little arrow over top of it like that. Okay? So that's just a couple of quick little notations. Let's kind of compare the two. These are sort of the couple of key ones for our calculations today, so let's make sure we understand the difference. So the first one we're going to look at is what's the difference between displacement and distance. So the first thing is displacement is our vector and distance is our scalar, but they both are similar, but you got to be careful. Sometimes they can mean a couple of different things. So distance, that's the most common one you would think of. So if I said you went from home to school today, you might have done a distance of, let's say, 5 kilometers. So you went from home to school, your distance was 5 kilometers. Okay, then at the end of the day, you're going to turn around and go back home again. So let's say you went another 5 kilometers. So if you went 5 kilometers to school, 5 kilometers back, you then have traveled a total of 10 kilometers to get to school and back. Okay, so that would be our distance. We don't really care about the direction, we just want to know how far you went. So the odometer on your car, if you were driving, would show 5 kilometers being added going one way, and it would add another 5 going back. Your odometer doesn't matter which direction you're going, it just wants to know the total distance you traveled. Displacement then would be a little bit different because let's say you went your 5 kilometers to school, and let's suppose you traveled east to school. We'll just write that in square brackets. So you went 5 kilometers east. Then at the end of the day, you're going to turn around and go back to your house. So you went 5 kilometers west. So now when we add those up, what happens? Well, 5 kilometers east, we can kind of think of that as being like a positive. Let me just clean this part up. Right? Because if we went 5 kilometers east, that would be like going 5 in that direction. And then 5 kilometers west would be going 5 in the opposite direction. So that would be sort of like our negative. So 5 plus 5 and minus 5 together would be 0. So displacement is distance with a direction attached to it. And the only thing that changes is when we total these things up, sometimes it'll cancel itself out, right? So if we went 5 one way and 5 the other way, we'd end up with a 0. Or another example is, let's suppose I say you're going to go 5 that way, then you're going to stop and then go another, say 7 that way, then you're going to stop and then come back 8 this way, and maybe that's it. So the question then would be, what is your total distance? So total distance would be 5 plus 7 plus 8 would be 20. You traveled 20 meters or kilometers or whatever the units are. But if I said, what's your total displacement? Then we'd have 5 plus 7 is 12. But then we're going to subtract 8 because it went the opposite direction. So really our displacement then is, we've actually, in conclusion, we've actually only gone 4 to the right or to the east. So our distance would equal 20, and in this case our displacement, we'll put a little arrow over it, would equal 4 to the east. Okay, does that make sense? And it doesn't matter, like I could have said kilometers for both of these, or meters, or whatever. It doesn't matter really what the units are. The key idea is you understand the difference between distance and displacement. Velocity and speed works sort of the same way, except we're just making sure we know one's a vector and one's a scalar. So velocity, we use v, it is a vector. Speed, typically we use s. It's not a vector, it's just the speed. So if I said I'm driving my car and I'm going 72 kilometers per hour, that's a speed. If I said I'm driving my car 72 kilometers per hour and I'm heading west, that would be our velocity. Okay, so we kind of changed the word a little bit, but in terms of the calculations, usually we don't have to worry so much about which one's which. They're both kind of the same. Okay, we're going to take a look at our first formula, and this one you should have covered in grade 10. So the first formula that we use is for calculating average velocity. And the formula that we use is velocity equals displacement divided by time. Okay, so these are both vectors. So velocity is a vector, displacement is a vector. My arrows aren't working very good. And time isn't a vector, because time has no direction, right? Time is just 10 seconds, 5 minutes, 10 minutes, whatever, an hour. Direction doesn't matter for time. So our formula, our first formula we'll use is just basically velocity equals distance over time, where those two are vectors. So on your formula sheet, if you look at it, you'll see that it has that. But
Shelley Hamilton, we are going.
On your formula sheet, if you look, this formula is there. It's the first one listed. And they also have a few other things listed. They have average velocity, like VAV, which is fine. We don't have to worry about that too much. And the other thing that shows up is they also put a little delta sign in front of the D and T, which just means the change in displacement and change in time. Those two you really don't need to worry so much about because they're just there to kind of remind yourself that when you're doing these calculations that you do worry about the difference in the distance and velocity, and we'll talk about that when we look at an example. So let's do a couple quick examples just to make sure we're clear on it. Let's do the first one, where we have, let's just do a simple one. Let's just say if we drive, let's say we're going to drive from Leduc to Calgary. So let's suppose from Leduc to Calgary we had a distance of 275 kilometers. And let's suppose we did that it took us, to go from Leduc to Calgary, let's suppose it took us 2.5 hours. The question is, what is our average velocity? Okay, so the trick is, can we figure out our average speed? Is it going to be our speed that we had in every particular instance? No. Right? When you leave, you might be driving 0, you're going to accelerate, you're going to get faster and faster. You might drive at 100, and then you're going to speed up, maybe you go for 110 for a little while. maybe you slow down for a bit, then you're going to speed up again. So throughout the entire trip, your speed would change, your instantaneous speed, and that's what your speedometer will show on your car, right? It'll just show you however fast you're going at that particular moment. But often we just want to know what the average, we want to know what is our average speed for the entire trip. So we can just use this formula, velocity equals distance divided by time, plug in our numbers, 275 divided by 2.5. Okay, you can write the units in here, sometimes that helps to keep track of them. And we do our calculation and we're done. So pretty easy calculation, 275 divided by 2.5 gives us 110. So our average speed was 110 kilometers per hour. Okay, quick review of our stuff from yesterday. So remember, when you're doing these calculations, we want to make sure we have the right number of significant digits, and we want to make sure that we rounded things properly. So the 110 is our exact answer off our calculator, so that part's good. But do we have the right number of significant digits? And the answer is no, right? Because our original question, we have 275, so that's 3 digits. Our time is 2.5, that's 2 digits. So we should round our final answer to 2. So depending on the question, if I gave you, let's change it first, that'd be easy. If I made it 2.50 hours, then we'd have 3 digits for each, so our 110 kilometers an hour would be good. But because it was just 2.5, we got to round this to 2 digits. So we want 1 and 1 would be our 2 digits, but now we have a decimal place issue. So that's where we'd have to change it to scientific notation. So we'd write it as 1.1 times 10 to the 2 kilometers per hour. Okay, I won't bother writing the kilometers per hour part, you get the idea. So we just have 1.1 times 10 to the 2 for the correct number of sig digs. So that's where yesterday's stuff is going to come important. You have to be able to round off all of your answers properly at the very end. So in this case, because we had 3 digits and then 2 digits, 2 is our least, we want to make sure our final answer has just 2 digits as well. Okay, so let's do another one. Let's try one a little bit differently. So let's suppose we're going to do a race. So you're going to have a runner, so a 100-meter sprint. So let's suppose our distance, our displacement is going to be 100 meters. And we're going to do that in, I think the fastest guys in the world can do it under 10 seconds, but we're pretty slow, so we'll say our time is, let's say it took us 16.5 seconds. Okay, so the question is, what is our velocity? So when you're doing word problems, sometimes this is a good way to do it, sort of label all the things that you know and what you're looking for, and then from there it sometimes makes it easier to solve. So our velocity in this case will be distance divided by time. So we'll go 100 meters divided by 16.5 seconds. So we do that, 100 divided by 16.5 gives us an answer of 6.0606, and it repeats. So be careful with our digits again. So we'll go back to original. We got 3 sig digs here, 3 there, so we want 3 for our final. So we're good. 6.06 is good. And our units then would be meters per second. And that's it for that question. So that's pretty good. So remember, we're dealing with distance, time to get our velocity, and our velocity, just divide them out. We don't really care too much about the vectors. That's usually not that big of a deal for these kind of questions, but because we're actually dealing with velocity, we will keep our formula as v equals d over t. This formula, let's just look at a quick variation. Because it's v equals d over t, sometimes the question might be worded to ask what is the distance or displacement traveled. So that one we could rearrange it to be d equals, if we rearrange the formula, the time would go up, so you'd have velocity times time. Or it's possible we could ask for time, and in that case we're going to move the v down, so you'd have distance divided by velocity. So all 3 of those formulas are the same, just rearranged for different letters. And we'll be looking at rearranging formulas sort of throughout the course, and when we get to harder formulas, a lot of times it's better to not rearrange and just adjust the numbers when you plug them in, but we'll get to that a little bit later on. So let's do maybe one or two quick questions using the other formulas, and we'll go from there. So the next one I want to give you, it says, let's suppose we were driving our car, so you're going to be driving down the highway, and let's suppose your speed is 110 kilometers per hour, and we're going to drive for a time of 1.75 hours. The question would be, how far did you travel? What was your displacement? Okay, so because in this case, we're looking for d, let's use the other formula. So let's rearrange it for d, so it'd be velocity times time. Plug your numbers in, 110 times 1.75. And we get 192.5. Okay, and we did kilometers per hour times hours, so you'd see, I didn't write the units in here, but let's just kind of take a quick look at that. If this one is in kilometers per hour, and this one's in hours, when we multiply them, you can kind of write that as hours over 1. You can see the hours would cancel, so our final units then would just be kilometers, which makes sense for distance, right? We're dealing with distance, we should just get kilometers. So let's just make sure we have our final answer rounded properly. If it's 192.5, we have 3 digits for the velocity, 3 digits for the time. So we'll round our final answer to 3 digits, so that would be 193. So 193 kilometers is our final answer for that one. All right, let's do maybe one more. Let's do a question where we're looking for time. So let's suppose, in this case, we're going to be, let's use meters again. So let's suppose we have a velocity of 25 meters per second. And we're going to cover a distance of 5.5 meters. The question is, how long did that take? What is our time? Okay, so same thing, except let's solve it for time this time. So it'll be distance divided by velocity. Plug those into the formula. You'd have 5.5 divided by 25. Actually, I'm going to change that a little bit. So we'd have 5.5 meters divided by 25 meters per second. So once again, just like with the other one, in this case our meters cancel, and because it's per second, that'd be the same thing as multiplying by the reciprocal, so that seconds would come up top. So our units cancel out, we just get seconds, which is good, that's what we want. So 5.5 divided by 25, we get an answer of 0.22 seconds. Do we have the correct digits? We had 2 in original velocity, 2 in our distance. Here we still have 2 because that 0 in front doesn't matter. So we're good. So 0.22 is our correct time. Okay, so those are just some fairly easy basic working with the velocity time formula. There's one other thing I want to look at today, and that is what happens when our our units aren't quite the same. So for example, if I said, let's say we have let's work with direction in this one as well. So let's suppose we have a car going backwards. So it's going in reverse direction and it's backing up at 9 kilometers per hour. Okay, so because it's going backwards, let's just use a negative to help us figure that out so we don't mess that up. And let's say it's going to do that for a time of 0.6 minutes. Okay, so the question is, what's our displacement? So these kind of questions, the only ones that are a little bit tough is to basically remember that you have to make sure our units match. So we have kilometers per hour for velocity, we have minutes for time. We're not going to be able to divide those, we need to make them the same. So we have a few different options. We could change our minutes to hours, or we could change the kilometers per hour to kilometers per minute, which might be more difficult. So let's just change it to hours. That's probably the best bet. So the first step then is let's change 0.6 minutes to hours. So we'd have 0.6 divided by 60 gives us 0.01 hours. And now we should be good to go. So our distance would be velocity times time. So we would have -9 kilometers per hour times 0.01 hours. So our displacement then is -9 times 0.01, which gives us 0.09 kilometers. Okay, but let's suppose the way the question was worded, let's suppose the question said, how far did it go in meters? Let's suppose the question was, what's its distance in meters? Say it was multiple choice or something like that. Maybe it would list the question as meters. So we could still solve it the same way, and then at the end we could just say 0.09 kilometers, change it to meters. Meters is 3 times 10 to the 3, so we move it over 3 spots, and we would say that's 90 meters, right? Because we'd go 1, 2, 3, add a 0 on, we would get 90 meters for our displacement. And because of the negative that was in the question, right, remember we were going backwards, so because we're backwards, we've got to indicate that direction as either being a negative again, or we could just say, in words, you could say the car moved 90 meters backwards or reverse. Okay, so just be careful if there's directions indicated in the question. You want to make sure your answer has directions. If it's not that important, then it doesn't matter which way you go. Okay, one other quick thing that comes in handy when you're doing these conversions, so like the way we did here, we changed the minutes to hours, then we figured out the meters, we did a few conversions. There's another one that works really good, and that's how do you convert from kilometers per hour to meters per second, or the other way around, okay? Those are two speeds that are both common, so typically when you're driving your car, you're going kilometers per hour, but often we're going to hear meters per second as well. And the conversion is quite simple. Kilometer to meter is 1,000, hours to seconds is 60 hours is a minute, times 60 again would be 60 times 60 is 3,600, so we'd actually have 1,000 divided by 3,600, which actually ends up being a magic number of 3.6. So we're going to use this conversion quite often, and you won't have to do any kind of serious work. You just got to remember to do 3.6. So if I gave you a speed of 100 kilometers per hour, if we divide by 3.6, that would give you what that answer is in meters per second. So that equals 27.7 meters per second. Okay, and we could do the other way. If the question was, say, given to us in meters per second, let's suppose it was 8.2 meters per second. All we have to do is times by 3.6. And that'll help us convert it to kilometers per hour. So 8.2 times 3.6 is 29.5. So we'll just round that one off to 2 digits because that's what I have my significant digits being. So that one is 2 digits would be 30. So 30 kilometers per hour. Okay, so you want to remember this 3.6 idea, and you want to be able to convert back and forth. So depending on the question, you might have to change it to meters per second, or you might have to just change one of the times like we did in the previous example, and so on. And we'll stop there for today.